Welcome back to this program on digital signal processing. In this section, our focus would be on design and implementation of FIR filter. So, to design and implement an FIR filter with the given specification, it is possible by using the inbuilt command in MATLAB, which is your an inbuilt app, which is called as FDA tool, filter design analysis tool, where you can design the FIR filter in no time. Now, instead of that, we'll be going into writing a program on given specification. A .m file will be writing in and you'll be designing it. The same thing can be designed using Simulink also, but in this section we'll be writing the program. We'll be covering the filter design analysis further when we go across this particular course. Now, a linear phase is required throughout the passband of a filter to preserve the shape of a given signal in passband. The causal IR filter cannot give linear phase characteristic, and only specially type of FIR filter that exhibit central asymmetry or symmetry in its impulse response gives the linear space. An FIR filter with impulse response h of n can be obtained by equation h of n is equal to h of t of n, where n varies from 0 to n minus 1 or equal to 0 otherwise. Now, if you go further with this, the impulse response h of d of n is truncated at n is equal to 0. Since we are interested in causal FIR filter, it is possible to rewrite the above equation alternatively as h of n is equal to h of d of n into wn of n, which forms my equation B, where w of n is said to be a rectangular window and is defined by w of n is equal to 1 when n is between 0 or equal to n minus 1 or 0 otherwise. So, taking the df ttft on both the sides, we'll be able to get h of omega is equal to hd of omega star w of omega. Now, the problem is we'll be designing an FIR filter to meet the specification choosing Hamming window with window length of 27, stop band attenuation of 50 dB, cutoff frequency of 100 Hz and sampling frequency of 1000 Hz. So once we write the code which was previously explained, which has been explained in detail, we enter all the specification, that is enter the window specification as n is equal to 27, cutoff frequency is equal to 100 and sampling frequency is equal to 1000. You'll be able to get the corresponding filter where you can see from this particular frequency, the 0.3 to this particular frequency, the signal is allowed to pass and the rest of the signal is being cut off. Similarly, you'll be able to see the phase of the corresponding output. So that's it from my side in this section. The detailed programming is also explained using the M file in the sections follow.